Here I have a sphere with some nails glued to it. The nails represent the electric field due to a point charge at the center of the sphere. Now we know that the electric field is radial, coming straight out of the sphere. At every point the field vector should be perpendicular to the sphere. And that's kind of the situation here, although we'll see how it differs. The point is that we can draw the same conclusion. We can draw the conclusion that the field has to be radial from the symmetry of the situation. Symmetry of the situation is this. No matter where I rotate this sphere, we have a charge at the center of the sphere. You can't see the charge. Let's just imagine there's a charge there. The charge stays at the center of the sphere. And if the charge stays at the center of the sphere, then the electric field at this point, no matter how I rotate the sphere, always has to be the same. So that, let's say the point I'm talking about is the top of the sphere. Okay, if I rotate the sphere from here to here, while you're not looking, you shouldn't be able to tell the difference. The electric field should remain perpendicular to the sphere. So if I rotate from any one of these positions to any other, you shouldn't be able to distinguish it. If there is a point at which you can distinguish the electric field, like this one, because we can see clearly that if this point is on top of the sphere, that electric field vector is not perpendicular. It's perpendicular here, but it's not perpendicular here. Okay, if there's any point where the electric field vector is not perpendicular, and also any point where the electric field vector is not of the same magnitude, then we don't have the symmetry that we think we have. Again, the point is that if there's a charge at the center, it shouldn't matter how we rotate the electric field, it should always be the same at this point where my finger is. Okay? If I rotate it here, that looks good. If I rotate it here, it's still the same. If I rotate it here, get it in the right position, it's still the same. But if I rotate over to this one, it isn't the same. That kind of rotational symmetry, that spherical symmetry about the charge at the center of the sphere, ensures that at every point of the sphere the electric field has to be of the same magnitude and in the same direction.